Hello, let's go through Unit 1, Lesson 5. Multiplication rule and independence. One, let's be clear. Anytime you use the multiplication rule, you're going to be using it to either prove or disprove independence. So if you see a question of independence, make sure you are using the multiplication rule, which we are going to discuss. First, if we have a bag of 12 Skittles and 12 of them are red, we're going to draw one from a bag one at a time, key being with replacement. That means we're going to draw it and then put it back. So the probability of the first one being red is going to be 12 over 36. And then if I put it back, the probability of the second one being red is going to be 12 over 36 as well. So when we multiply those two things together, that's going to be 144 over 1296. So if we do the same example, except now we're going to draw two without replacement, because we're going to eat it, meaning we're not going to put it back. So it's without replacement, which is going to change our probability for the second draw. For the first time, it's still going to be 12 out of 36. But now, for our next draw, it's going to be 11 over 35, which when we multiply them together, is going to be 132 over 1260. So you understand the difference of probabilities with and without replacement. So two events, A and B, are independent if the occurrence of one event does not affect the probability of the other. So we have the example here, independent, getting a 6 on the first event, the first time you roll a die, and getting a 6 on the second time. That would be independent. Dependence would be getting a 6 the first time and then having a sum of 8 on the second roll. So as we go through these examples, if I toss a penny and a nickel, the probability of the penny does not impact the probability of the nickel. That would be independent. Getting the heads on tossing a coin and rolling a 5. One event has no impact on the other. That's also going to be independent. Choosing a red candy from a bowl, replacing it, meaning with replacement, and getting red on the second candy, that's going to be independent. But if I do the same thing and it's without replacement, that makes it dependent. Okay? And that's important to figure out. So with replacement, independent. Without replacement, it's going to be dependent. So now let's look at our next page of notes. So our rule itself, two events, A and B, are independent if and only if the probability of A times the probability of B is equal to the probability of A and B. So again, anytime we have a question of independence, you're going to use the multiplication rule. So if we look at this first example, we have the probability of A is 0.35 and B is 0.2. And we're given that the two events are independent, which means we need to multiply the probability of A times the probability of B, which is going to give us 0.07, because we're, again, multiplying the probability of A times the probability of B. Once we have the and, we can use our addition rule to find the probability of A or B. So you would add the probability of A plus the probability of B, and then subtract the probability of A and B. So addition rule for or, multiplication rule for independence. So pause the video, see if you can do the next example on your own. Okay, so we have a question of independence, and again, when you have that question, you're going to use the addition rule. The multiplication rule. So we're going to be multiplying the probability of A times the probability of B. So 0.3 being our probability of A. And we're going to multiply that times the probability of B, which is, in this particular case, 0.4. And that should be equal to the probability of A and B. When we do, that is 0.12, which in this case is not equal to 0.25. Okay, so the answer to the question is no, not independent. And the reason being is that the probability of A times the probability of B is not equal to the probability of A and B. So again, you're going to be making sure you use the correct notations for your explanations. Okay, that's going to be important. So to recap, things that you must know. With replacement, again, it's independent. So if we look at this example, we have a total of 8 chips, 3 of them red, so the probability of getting red both is going to be 9/64, 3/8 and 3/8. But if we do the same thing again without replacement, that changes the probability of the second one to 2/7, which makes the probability of both being red to 6/56. So without replacement, again, it's dependent. With replacement is independent. So mutually exclusive, we know the two events cannot happen at the same time, so the probability of A and B being 0. Independence says each event does not affect the other's probability. The probability of A and B are not 0, which means independent events, you will always have an intersection. So make sure you are mindful that these two events cannot happen at the same time, being independent and mutually exclusive. It can be neither. So you don't necessarily need one or the other. You just need to make sure you cannot have both. Okay? So make sure you complete worksheet 1.5, and I'll see you soon.